One of the most impressive things about Enroute is its toolpath engine, the ability to easily apply complicated toolpaths to objects with just a few button clicks. Before you can apply toolpaths, however, you need to have some geometries to cut. So here for this example, we're going to vectorize this bitmap. And this is just a logo from a local company. And we're going to go to the draw menu and go down to the vectorize bitmap feature. And there's a couple methods here. Enhanced curves works well on low resolution artwork. But this particular artwork doesn't have a resolution problem. It's just a little bit fuzzy around the edges. So we're going to go with enhanced corners. And this gives us some ability to filter out some noise and different characteristics of a scan. So we'll hit the OK button. And now we can actually just scroll between layers here. And then the original layer will create the geometries. I'm going to move it up into the plate by hitting Control and the 5 from the number pad. And I might take a quick look here just to make sure that we've done a good job of giving smooth geometries here. And everything looks pretty good so far. Now here we see there's a little bit of distortion we might want to take care of. So I can do that any number of ways here. One way I can do is go to the smooth curve tool. And here I'm going to click on one side of the curve and then the other. And just hit the enter key, and it'll smooth that around. And let's go over here as well. Click one side of the letter and the other, and we smooth that out. So that seemed to be really some of the only areas there. Maybe I'll do one more here just to smooth this side out. And if I had some exact text, I might need to take a little bit more time and do an exact type of point edit. But this is just something really quick to smooth out a particular area. All right, so once we have the text that we want on screen, I'm actually just going to make this a little bit smaller and then center it. Now I have a 30 by 20 plate size here. So I'm going to create a rectangle that is 28 by 18. And I can place it somewhere precisely here. I could say the lower left-hand corner should be at a location of 1 in the X and 1 in the Y, or I could have just centered it the same way I did the Ogilvy here. So now we have some text on screen. Once we select it, you'll see the outer contour is blue, the inner contour is red, and then blue. This is an alternating sorting method, and this tells us when we toolpath it, we're going to toolpath it from blue to red. Red will be raised. So I'm going to go to the toolpath menu and choose the island fill. Now I could select my tools manually, but if I have a pre-existing strategy, I can select it and hit the apply button, and this will be several different tools that are used. A larger tool to do the clear out, a 3/8" end mill, an 1/8" end mill to do the smaller little detailed areas, and a tapered bit, a 90-degree tapered bit or conic bit to do both the tapered area around the letters and contours and then get into these tight little areas. So just with one button click, I can apply a very complicated toolpath here. Now I'll create one more rectangle the size of the part, and I'm just going to place that on screen and hit Control 5, and that centers it right in the plate. And I can come here now and apply a routing offset toolpath, and in this case I'm going to go just a little bit deeper than the material. This already has my entry exit parameters included, and if I wanted to, I can actually determine where my entry exit is by setting a pre-existing factor in the preferences, and now I will have it be in the longest line segment. So if I delete and re-imply my toolpath, and it remembers the last toolpath, so I just had to hit OK, it gives you the toolpath and the entry exit point down here at the bottom. Now I'm going to hit Control 1 to locate that at the lower left-hand corner of the plate, and now I can redefine my plate to either be the size of my material I'm going to cut, or it could be just made the size of the part that I'm cutting. So this is how easy it is to toolpath and routes, to toolpath using Enroute's toolpathing abilities. I'm actually going to go ahead and make this fit my selection here, and we'll do a quick simulation to get an idea of what this is going to look like. And here we can see each of the different aspects as we zoom in, or we could set it to animate it and see the bit moving around here, but we have it sped up a little bit. And this gives us an idea of what the finished result will be, with a 3D engraved toolpath included with an island fill, and we just have the text and the logo left standing. One of the things you have to do a lot when you're working with other software programs like Corel or Adobe is you have to import files that may sometimes have some overlapping components. Another factor you have, and this is working with any kind of CAD program such as Corel or Adobe or possibly AutoCAD or some other CAD program, is that when you import a geometry, you might have a lot of control points there, and these are going to help, or these are going to cause a not as smooth as possible cut as you might get if this was a smoother output. So Enroute gives you a number of tools to handle situations like this. First thing I'm going to do is select all these contours, and then I'm going to go to the Draw menu and go down to Cleanup. What Cleanup does is it's going to get rid of all the unnecessary control points, and I'm going to use this little factor down here to determine how much I'm going to change the original geometry during this process. So if I come down here and set it to a real low amount, 0.003, then when I hit the OK button here, I'm going to go from about 2,500 points down to 319. So with that big of a reduction in points, we're going to have a much smoother cut here, but yet we've maintained the very close to the original look of the letters here. And the lower you put that value, the less you'll change from the original look of the letters. So that's one way to make sure you get a better cut when the parts are cut out. Now when it comes to getting rid of some internal components here, one thing you can do is go in here and select each of these parts, and sometimes you can weld them together. So I can come here to the transform menu and go to weld join, and that will weld out the parts I want to get rid of. But when you do another part, it might not get rid of quite what you want to get rid of. So the way to do a nice manual weld is to come here to the Draw menu and go to the Trim tool. And by using boundaries and going ahead and telling it all boundaries, that means each particular area can become a cutting point. Now I can use my scroll wheel to zoom in real close to these tight areas, and as soon as I put my cursor over one of the contours, it'll turn blue and show me where it's going to cut it if I decide to get rid of that point. So here I'm deciding as I go through here whether I want to keep a particular inner or outer contour, and if I zoom out and then zoom back in, I can focus quite easily in on another area. And if I have a snap where I'm too far away and I'm having trouble with the interface deciding which one, just scrolling in just a little bit will help to resolve that. All right, so as I go around here, I'm just clicking on each of these areas, making it quite easy to get rid of the parts you don't want. And when you select the shape and Enroute, it's going to tell you a little bit about the part. Pink means it's an open contour, and here you can see a little arrow showing you the open contour direction, and blue and red are closed shapes. So I actually see one more little area here that I failed to get, so I'm going to go back to the Trim tool and remove that. And if I've done a good job here, when I select everything and right click it and say merge selection, it should turn back to blue and red. And if it does turn back to blue and red, then that means I've done a good job of cleaning these up. So the cleanup, the Trim tool, which also comes with an extend, and the cleanup selected contours are both great tools for cleaning up files that are coming from other programs. Enroute's Auto Toolpath engine is one of the things that helps to set it apart from other graphic programs. And how Auto Toolpath works is it allows you to take layered DXF files, whether it's directly from a CAD program or from a parametric design program specialized for cabinets or flattening solid models, and take these layered files and automatically toolpath them, nest them, create the output and order all within a few button clicks. It also creates layered printouts to help with part location and labels to help identify parts. How the Auto Toolpath works is you go here to the Auto Toolpath button, you go to the Setup tab, and you select your design application from a list of applications, and Enroute is used by worldwide applications that like the ease of use of how Enroute works. Now you select whether you're going to output your files, do the layer printout and labels, and a few other variables. Here we're going to select the files that we're going to cut for this particular job. And we're going to make sure that we have all the layers assigned and the ordering and nesting taken care of. Once these variables are set, and basically you can do this by just opening the file, you can come here and hit process, whatever the particular application is, or process files. And the process of toolpathing, nesting, and creating the order and output will all happen automatically. We have all the output files created in the desired folder, and we're ready to begin cutting. Together with the layer output to help with part identification and labels, Enroute ATP is a very powerful solution for nested-based manufacturing. One of Enroute's 3D surface creation tools is the ability to work with mesh files, and this can be used to help recreate a part that was designed as a solid in a program like Rhino or Inventor or SolidWorks, or you can use it to work with 3D clip art that's available in mesh format, or any scanned object that's been scanned with a laser scanner or via some other method. So these files are typically STL files or DXF or 3D Studio. There's a number of 3D formats. For this example, we're going to import a 3D molding that's an STL file. Once the mesh is on screen, we can select it and you'll see it turns green. And if I go to the top and double click it, I'll get to the side view and I can make sure the mesh is in proper position in the Z-axis, resting right on top of the plate. Now I'm going to create a 2D shape that I'm going to use to create a relief. And I'm going to create a rectangle here that is 13 inches by 6 inches, and we're going to put it at a location of 0 by 0 in the XY. So down here in the lower left corner, and hit apply. Now we're going to go to the point edit mode, and we're going to click on the point in the upper left hand corner, hit the F2 key, and we can move this over 1 inch, this point 1 inch to match the corner of the mesh object. And then we'll click on the lower right point and put this to a X position of 12. Now I've got a 2D shape that's the exact size of the part that I want to add to it, the 3D mesh. Now I'm going to select both objects, and I'm going to come here to the Create Relief button, and I'm going to create a flat, no thickness relief with a resolution of 100 dpi. This is going to be the relief that I'm going to then apply this mesh object to. Now I'll select both the mesh and the relief. I'm going to hit Apply Mesh to Relief, Add, and Apply. I can turn on the highlighted view here, the rendered view, and see that the mesh and the relief are occupying the same spot, and now I can turn off the kind of combined view and see just the mesh object here. If I go to the side, I can see it's resting on top of the plate. Now I'm going to go to the surface menu and go down to the alignment tool and move it so that the relief is just inside the material. Any leftover material is here at the bottom of the relief. Now I have saved some toolpaths here to make it easier to toolpath this part. And I'm going to come here and go to the hatch fill. And I'm going to go to my list of available saved toolpaths here. And I have a 3D molding rough tool selected. And I'm going to hit the OK button here. Now that's going to be a rough tool that's going to do a 2D pocket, another rough tool that's going to follow the surface. And I set the parameters for those in here prior to applying it, but once you have everything set up, the process of applying a toolpath is quite fast. Now we're going to apply a more detailed toolpath, and this is going to go down to a depth of 0.65 inches and a higher percentage overlap here of 90%. And the rest of this material will have been cleared away, so that makes this process a lot easier, and I won't have to worry about this tool removing too much material. Last, I'm going to apply a routing offset with a 1/2 inch tool just to clear out some material around the edge of the part. And that's going to also allow me to see the edge and not have to worry about any of the debris that might be left over, the material left over. Now I might want to do a quick simulation on this part. So let's go to the perspective view here and align it to a position that we want to see it. We're going to go to the 3D simulation here. We're going to check our tool order out and see that we're cutting the end mill first, then a ball nose, then the 1/8 inch ball nose, and the 1/2 inch bit. So that's the order we're going to follow. I'll tell it to simulate the first tool cutting, and we can see it removing a 2D rough pass there. The next tool is actually going to follow the surface, but offset somewhat from the surface, so it'll leave just a little bit of material. The next tool is going to come in at a higher percentage overlap, and it's going to remove the material that was left during the rough cut process. But since we only left a small amount of material, it's not going to overwork this smaller detail tool. And finally, we're going to do the cutout, which is just going to show us a clean edge on the sides. So this is how easy it is to take a mesh file, add it to a relief, create the toolpaths, and be ready to start cutting, all using Enroute software. In a program full of impressive features, Rapid Texture just might be the most impressive. It gives you the ability to create pictures, to make furniture, create 3D objects, and create decorative pieces just as wall panels by themselves. How it works is actually a pretty simple process. First, we need to create the seed contour. For this example, I'm just going to draw a straight line across the center of the material. Now we need to go to the Rapid Texture tool. So first I'll create the seed contour and go to Rapid Texture. Now I have a panel size, which is the same size as my plate, which is 30 by 10. I'm going to exceed the overlap there past the edge of the part a little bit by 0.2 inches. There's a few variables here that I'm going to set. And once I have all the variables in place, then I can hit the apply button. What happens is a series of contours get created that are offset values from my original seed contour, and random distortion is introduced into them. The more distortion there is, the greater the lines will move from their original shape. Now I can just reposition these parts in the z-axis just as 2D contours, or they're just shapes at this point. And I'm going to make sure no snaps are on here, allow me to move it around freely. Now I'm going to come here to the Engrave toolpath and choose a strategy where I have a 1-inch ball nose tool saved, and I have follow contour checked, which is important because that makes the toolpath, or the tool selected in the toolpath, follow exactly whatever the geometry that it was selected was going to do. So this is going to allow a tool to go back and forth across the material and move randomly as it goes back and forth across. So let's zoom in here and make sure we're checking animate here so we can see the bit go back and forth when we hit the play button. And as the bit goes back and forth, you can see that it's going to move and wiggle, and that wiggling action following the random distortion is what helps to create a texture. So this is the process of Rapid Texture, and there's a number of things you can do. As we said, you can incorporate a picture. You can actually include a 3D surface or 3D relief along with the texture and have the texture create the relief. You can create rows and columns of parts or use symmetric matching parts, and the Rapid Texture function is really quite useful for creating a number of parts. And we thank you for taking this time to watch a demo of Enroute software. Please be sure to check out a lot of the other resources available on the website.